In this video, we will discuss some stoichiometric conversions from balanced chemical equations. So the first conversion I'm going to talk about is mole to mole conversion. So the first question here is the combustion of propane is represented by the balanced chemical equation below. How many moles of propane are required to produce 3.34 moles of water? So what I will do, first I will check whether the equation is balanced or not. So it is balanced. And then I will look which are the two compounds of interest here. I can see how many moles of propane. So I will identify the propane from the balanced chemical equation and are required to produce 3.34 moles of water. I will identify where is water. So in this case, we have one reactant and one product. And then what I will do, I will start with the given quantity, which is 3.34 moles of water. And we have to find how many moles of propane. So how many moles of propane? So propane is C3H8. So and now I will arrange the conversion factor in such a way that moles of water will cancel and I should end up with the moles of propane in the numerator. Okay, so I will arrange the moles of water in the denominator first. And I will look at the equation to see how many moles of water. I have 4 moles of water for each 1 mole of propane. Right? So now I can cancel moles of water and moles of water, and I have moles of propane in the numerator. That's what we want as per the question. And now we can write only the numbers in the numerator, that is 3.34 times 1 mole of C3H8 divided by, I have 4 in the denominator. So the numbers are 3.34 divided by 4 and I will get the answer 0.83 moles of propane. And now we will see a conversion between mole to mass. Okay, so how many grams of carbon dioxide are produced when 2.10 moles of oxygen are used in the chemical equation? C3H8 plus 5O2 gives 3CO2 plus 4H2O. So first what I will do is I will see the compounds of interest here. How many grams of carbon dioxide? I will mark that carbon dioxide in my equation, and 2.10 moles of oxygen. I will look where oxygen is and I will mark that one. So these are the two compounds I am going to relate. So the relationship between these two compounds we will find. And now I will start with what is given, 2.10 moles of oxygen. So I will write 2.1 moles of oxygen, and I will see the conversion factor between oxygen and carbon dioxide. So I don't want moles of oxygen. I want what they're asking, the grams of carbon dioxide. So I will write how many grams of carbon dioxide will form. Okay, so I need the grams of carbon dioxide in the numerator and I want to cancel all other units. So first I have to start with cancelling moles of oxygen because that is what I started with. And now I will look in the equation. So I'm going to connect the dimensional analysis with the equation. So that means for 5 moles of oxygen, so the mole ratio is 5 moles of oxygen gives 3 moles of carbon dioxide. And now I can cancel moles of oxygen and moles of oxygen. And now again, I don't want moles of carbon dioxide. I need grams of carbon dioxide. So I know in 1 mole of carbon dioxide, I have how many grams? 43.9 grams of carbon dioxide. If you take the masses from the periodic table, you can see that carbon is 12.01, oxygen is 15.99. I have two oxygens, so 15.99. That will give you 43.99. Okay, and now I can convert moles of carbon dioxide and moles of carbon dioxide, and I ended up with grams of carbon dioxide. And now what we have to do is take the numbers in the numerator, 2.1 times 3 times 43.99 divided by, in the denominator I have 5 times 1, and what is left, the unit is grams of carbon dioxide. So that equals, when you multiply those numbers, we will get 277.137 divided by 5. I will not round until I reach the final answer. Okay, so I will leave all the numbers like that. So that will give me 55.4 grams of carbon dioxide. So how many significant digits I need? 2.10 means I need 3 significant figures. So I can write 55.4, that is correct significant number, grams of carbon dioxide. Now let us see another conversion, that is mass to mass conversion. Even in mass to mass conversion, first we have to convert it into moles so that it will be easy for us to connect with the equation, balanced chemical equation. So the combustion of propane is represented by the balanced chemical equation below. How many grams of propane are required to produce 60.3 grams of water? And the equation is given, and I double checked, it is balanced. And now we can start our conversion. So that means we have to see which are the two things we have to connect is propane and water. So I will mark that one, propane and water, correct? Okay, so now what we have to do, start with what is given. So I have 60.03 grams of water, and I don't want grams of water, I need moles of water. First I am converting to moles. So what I need, I know 1 mole of water has a molar mass of 18 grams. So I will write 18 grams of water in the denominator so that I can convert that one into moles. So grams of water and grams of water converted, and now I have moles of water. And now I'm going to connect that one with my equation. So for each 4 moles, or the mole ratio between the water and propane is 4 moles of water and 1 mole of propane. That is the mole ratio from the balanced chemical equation. So moles of water and moles of water cancelled, and I connected that mole conversion to the equation. Okay, so now what I need is how many grams, right? Grams of propane. So what I will do, the moles of propane in the numerator, I have to convert it to grams of propane, and I want to cancel moles of propane. So I will write in the denominator moles of propane. 1 mole of propane, C3H8. Each 1 mole of propane is, the molar mass is 44 grams of propane. So I have now the grams of propane, and now I cancelled moles of propane and moles of propane. I have the grams of propane in the numerator, which is exactly what I need. And now I will just write the numbers in the numerator, 60.03 times 44. I am not writing 1, it is not going to make any difference, divided by 18 times 4. And what is left on the numerator, the unit is grams of propane. So that equals 36.65, and how many sig fig I need? 3 sig fig. So I can write that one as 36.7 grams of C3H8. And now let us say a conversion that is between mass and volume. Okay, so for this one, what the question is, how many liters of oxygen gas are required to react with 46.5 grams of propane? So first what I will do, I will see which are the two components we have to connect, propane and oxygen. So I got that, and it is a balanced chemical equation, and then I have to start with what is given. 46.5 grams of propane is given. I don't want the grams. I always convert it into moles so that it is easy for me to connect with the equation. So I know the grams of propane in 1 mole. So I will write the grams of propane in the denominator. When I find the mass of 1 mole of propane, I see that it is 44 grams. So that is, in 1 mole of propane, I have 44 grams of propane. I'm writing the grams of propane in the denominator so that I can cancel, because I don't want that grams. And now I can connect the moles of propane with our equation. So that means 1 mole of propane, the mole ratio is, that corresponds to 5 moles of oxygen from the balanced chemical equation. So I can cancel 5 moles, moles of propane and moles of propane. And they are asking for the volume. So I don't need the moles of oxygen. And I know the conversion factor between moles and volume. So 1 mole of oxygen at STP. If it is not mentioned at STP, it should be at STP. So that 1 mole is 22.4 liter. Okay, so 1 mole of oxygen is 22.4 liter of oxygen. That is, moles of oxygen and moles of oxygen cancel, and I am having the liters of oxygen in the numerator. That is what is required, correct? Because they are asking how many liters of oxygen. So now I can just take the numbers from the numerator and multiply and divide with the numbers in the denominator. So 46.5 times 1 times 5 times 22.4 liters of oxygen divided by the numbers in the denominator, 44 times 1 times 1. So that equals 44. Okay, so that equals 118 liters. I need 3 sig figs, so that is exactly what we have.